Thanks for having us, and I think this is a joint presentation from SCIEX, Boehringer, and Bayer about like mass spec integration in our we show LIMS interfacing and also archiving use cases. And so we will have three presenters: Blair as the technical lead and solution architect from SCIEX, Paul James Jones, Information Technology Officer at Boehringer Ingelheim, and myself, Digital Transformation Lead at Bayer Crop Science. Yeah, I'm like to give you like the broader perspective and share the vision we have behind this this endeavor. So I think the Bayer's vision was, or it still is, to work on a data-centric digital lab, and this is basically like a four-step cycle that we envision there. So starting with an hypothesis before an experiment, going on with automating scientific experiments, harmonizing data, and then in the end evaluate, and which the evaluation leads into like a repurposing for the next hypothesis. And so through this like data empowered scientific evidence generation, the present project is one example of that. And I'd like to show you the context where we embed this. So the idea is, and this is one implementation that we have at Crop Science. There will be others in the pharma space as well, where we actually try to streamline the LIMS interfacing in general. So basically decoupling from like bilateral interfaces towards like a standardized interfaces using the ADF as the import format for LIMS. In this case, the star LIMS use case in Spectra. So this is a use case from the Human Safety Residue Analytics LIMS. And as you can see, we're jointly working on in this project is basically the SCIEX Analyst extractor going through a WebSocket where the ADF is generated, and then this is stretched to the LIMS. The original raw data is pushed through a SDMS system, then to also an Allotrope-based e-archiving system, the GEAR system. And the beauty about this is that we basically have separated the vendor-specific part here to the left to the instruments machine, having very small executables there, and we have an vendor-agnostic WebSocket part. That where we build on the ADFs and have convert actually specific taxonomy things to the Allotrope ontology, and have in the end like a valid ADF, and this makes this interface very, very universal, and the use case applicable beyond that. And so this is basically our setup where we implement the LNS extractor that we are going to see in the next steps. But I'm going to hand it over to Paul then to share his view on this.
So you can share the next slide, please, and I'll speak to it. Okay, great. If you could build the slide, that would be great. So BI's near-term interest is in producing a vendor-agnostic ADF file for long-term data preservation. Some people call it archiving. For analyst triple quad mass spec data in the DMPK bioanalysis area. Concomitant with producing the ADF is a requirement to be able to review that ADF content in a vendor agnostic viewer, ADF Explorer. So if you think about producing data and then need to review it 10 years, maybe longer after the fact, it's helpful to have a vendor independent viewer, a vendor agnostic viewer. So our initial emphasis is on instantiating the results table and the associated chromatograms, the TIC and the XIC in the ADF. Now, this initial development or evaluation effort is non-GXP, but there's a strong requirement internally to ultimately validate this conversion for real use. Next slide, please.
I'm trying. Yeah. it's not. There it is. Sorry.
Okay, great, thank you. And so in this scenario, it's not actually all that different from what Henning presented. On the left, you have the instrument and you have the associated software, in this case, Analyst. And the important piece of it is, at least in our implementation, it will be a manually triggered process. So when the scientist finally approves the data for archiving, that will be a manually triggered process, and then that data will be handed over to the converter, which will then create an ADF and then deposit that in temporary transient storage, which will then be swept up by our BI data management infrastructure and handled internally. And so this is sort of the overall workflow for the ADF files. And I just want to show you in the next slide. Next slide, Henning, please. A few very initial screenshots. So up in the upper right-hand corner, you see the representation portion of an analyst screenshot directly from the application, and you see the corresponding information in ADF Explorer. So once you know what to look for in ADF Explorer, it's relatively straightforward to be able to find the information that you would have needed in former times. You would have needed Analyst to be able to view. Now we can view that outside of Analyst using this ADF file in ADF Explorer. Next slide, please. And this is just a sample of some of the chromatograms. I'm just seeing if you're paying attention, because these are actually not extracted ion chromatograms. These are total ion chromatograms. But it just shows you for several of the samples that you can actually view the associated chromatograms within ADF Explorer, again, from that ADF file. And now I'd like to hand it over to Blair, that's going to talk a little bit more about some of the implementation details and some finer aspects of this converter.
Thanks, Paul. Can you hear me?
Yes, we can.
Okay. Hi, everyone. Blair James of SCIEX. As you've seen, the high-level architecture that we've used is based on a WebSocket interface. So a local client application extracts data from the native application, the vendor-specific application, converts those data to a JSON message format, transmits that to the WebSocket, where the conversion to an ADF file is performed. Next slide, please. So a more detailed representation of the SCIEX implementation. We have the Analyst software. We've created a data model that wraps all of the APIs and all of the data produced in the Analyst software. And we have created the ability to plug in a WebSocket driver in the client code. Roughly, the WebSocket driver corresponds to a use case. And you can see here that we've already produced a LIMS interface driver and an archive driver. We also have the ability to convert to XML, or the ability to produce additional drivers for the WebSocket for whatever format we're interested in. Outside the Analyst environment, the JSON message is fed to either one universal WebSocket, or we have the capability of running multiple WebSockets simultaneously that do whatever conversions we like to do. Next slide, please. So that architecture gives us a few advantages. One is scalability. You can imagine placing the WebSocket up in the cloud on an AWS machine or in a private cloud, and being able to devote whatever computing resources are necessary to deliver the performance we require. It's also very extensible. So as, of course, we support the Allotrope data format, but in addition, we can support other formats of interest. Next slide, please. So this is a quick overview of the user interface. We have the Analyst software displaying a results table. So the analyst workflow is essentially that we would prepare samples, we would create a sequence, we would acquire the data from the samples, producing a raw spectra file called a WIF file in Analyst. We would create a quantitation method along with whatever parameters for integration or regression that we want to use, identifying internal standards and so on. And then review the results table, including looking at the chromatograms, perhaps adjusting integration parameters on a per sample basis, maybe performing manual integration. At some point, we are ready to transmit the results table. We're done and happy with it. And we have a menu option over on the left-hand side of the analyst window that will launch our data extractor. The data extractor presents us with a summary of the results table. We can also drill down to additional details here and gives us some options for the destination of the ADF file naming, and so on. That's quite flexible, and it can be configured in preferences. So this can be either manual or semi-automated. When we're ready, we press the convert button. Next slide, please. And the converter displays status to us. And we can see if there are any problems, for example, transport errors or network issues. But generally, we receive a conversion completed successfully message. Next slide, please. So for our two use cases, let's talk about the archival use case. We can see here in ADF Explorer the graph. This particular use case includes all of the data that are available to us from the analyst software, including TICs, XICs, all of the metadata, acquisition information, quantitation parameters, and then everything that we have in our result set at the end. Next slide, please. Oh, one comment on the data description. We've modeled that in a proprietary, at least a vendor-specific model, primarily using leaf nodes. Here we see, as Paul showed us, in the data cubes, we store the raw spectra for each sample and analyte. And this is the default viewer from ADF Explorer. And so you can see that it's showing us time versus intensity. Eventually, when we get to a custom viewer for this application, we would pretty this up and be able to see the additional labels and information and where the peaks are drawn and so on. Next slide, please. So let me go back one. So in the data package, we store all of the source vendor-specific files. So we have the raw spectra file, we have the completed results set, we have the audit trails. Within the results table and with file, all of the acquisition parameters and quantitation parameters are preserved. So this represents a pretty complete set of data for use in archival, or for that matter, for any other use case. The user is also given the option to attach whatever files to the data package in the ADF. So for example, PDF reports or sample lists or anything that they like. Next slide, please. So for the LIMS use case, we have a small data set, which it only includes parameters that are of use to the LIMS. And so I think we have on the order of about 50 data elements there. When we mapped and modeled that, we found that 95% or so of terms are a good match. That's a little bit misleading. Overall, that won't happen for the archive use case. It's because we had this small set of very common terms. A small number of those are either Bayer or SCIEX specific, and we've used a custom data shape for that. Next slide, please. The modeling for this use case, it includes most of the data from an MRM experiment. Haven't yet modeled it. This is actually for the archive use case, sorry. We haven't yet modeled it using the Allotrope taxonomy and data shape. The data description contains metadata and tabular data, TIC and XIC data in the data cubes. One comment about this conversion, placing the TIC and XIC data have been surprisingly performant for us. It's been quick. Now, that being said, these are relatively small sample spectra, probably on the order of a few thousand data points. If we were doing, if we were running TOF data, for example, or swath data, that would probably be a different story. We have implemented the support for MRM experiments. We will be adding other scan types as time goes on. Next slide, please. So we have some work planned. We plan to produce a data viewer which will plug into ADF Explorer and likely also be able to be run standalone. This data viewer would show us, as I said, the detailed chromatograms as well as the tabular data from the results table, acquisition information, and so on. At some point in the future, we plan to harmonize with the final MS data shape. It remains to be seen how soon that will happen, and it's possible that we would take the terms that we have used in the custom model and map them to Allotrope, send that portion of it through governance. It really depends on what gets produced by the MS data shape working group and when that becomes available. We need to implement GLP support, so we would be producing software validation documentation, user documentation, and so on. Next slide, please. So thank you. We've had a lot of fun with this project, and it's been encouraging to us how powerful and easy to use the ADF APIs are, and we look forward to further development on this. One final comment is that the SCIEX OS software, which is our next generation instrument control software, we do have plans to implement a similar utility for that software. Next slide. Okay, so any questions?
You can raise your hand or indicate in the chat if you have a question. I'll just say that was actually really great to see both the partnership and the progress, on a new major technique. you know, I know myself and any number of companies are definitely going to be interested in continuing to see the PK use case move along, and I think could, you know, definitely be, we could rally some more effort around taking some of this and moving it forward, you know, in the working group and continuing to enhance it. And I think, you know, I'd actually really encourage you to provide these use cases to that group as, you know, as fodder, something really to focus on and work it forward. That's always a much more sort of productive approach.
We have a question in the question window. Will the leaf nodes be replaced by full ontologies once these are available?
Yes, that is our plan.
We have another question. To what extent has mapping to IDMP been considered?
To a very small extent. It's out of scope for this particular portion of the project, although that's something we can consider in the future.
Yeah, maybe just a comment from my end. We did IDMP assessment for analytical or chemical analytical data and on other projects, and our takeaway was that the actually IDMP required fields are a lot more high level than actually the things that we are talking about here. So the granularity in this aspect is, yeah, no, 1 or 2 orders of magnitudes higher than that's what's required for IDMP solutions.
Hi, this is Dan. I'd have one more question for Blake. From it is like, can you say anything about what you might have for plans for this being available sort of more broadly and commercially? It's an exciting step forward.
So that's a bit above my pay grade. We have Dave Abramowitz on the call. If we could unmute him, maybe we could ask him to comment on that.
I'm ready. Can you guys hear me yet? Oh, there we go. I'll send you my contact information and we can discuss it. We're looking at ways to make this more commercially available as part of special licensing packaging within analysts. So we're certainly looking at that. If you'd like, please send me or send Blair or Henning your contact information. I can get that back to you and then we can start discussions on that way.
Okay, and then there was a follow-up.
Good.
Sorry.
So just a quick follow-up here on Dana's request for Dave and the team. Again, this is Vinny Antonucci from Allotrope. Awesome progress. I would just maybe echo some of Dana's comments. You know, instead of, you know, I love what you've done and the intent to merge it with things that come out of the working group, but I actually strongly encourage you, since it seems like you have some pretty elegant solutions using the APIs for several parts here that actually perhaps consider reversing that and really driving the actions of the working group by contributing the parts here that you've done as a data model. It's going to probably be as fast or faster way of getting a consensus data model. So I just encourage you to seriously consider that. I think you can drive the MS working group. Thank you.
We absolutely agree with that, and you know, we are committed to Allotrope, and we would love to be as involved as we possibly could. There are, of course, our resource challenges with everybody, and that's something that we'll have to explore.
Yeah.
But yeah, absolutely, and you know, you guys know, SCIEX and myself and my team, we're fully engaged and we're fully committed to Allotrope. So you have our commitment that way.
Perfect. Yeah, we'll talk offline. We'll make it happen. Thank you.
Great.
All right, there was one other follow-up question to the IDMP question, just the units of measure.
So, sorry, I didn't get that. And just
yeah, maybe I'll unmute Hans and you can ask it directly. There you go, Hans.
Hi, thanks for this wonderful presentations. Really good. But I'm really more interested in IDMP actually and mapping to that. Now I saw that you had just values in there, but not the units of measure. Have you tried to harmonize for the units of measure, and also in this respect that you have a certain integer with a unit, a subunit, and so on?
So actually, we have included units of measure in the data model that we've used, and those are using standard terms.
Yes, and those units of measure are visible in ADF Explorer. I didn't include that in the screenshot that I showed, but the units are there as well.
Wonderful. Thank you.
All right, and then we have Corey, you have a question? You're unmuted now.
Yes, hi everyone. Just a quick question. I noticed in the schematic here, you're using WebSockets, and I was wondering if you might be able to comment at all on, if this opens up the ability to use the Allotrope APIs from other languages other than Java and C#.
I don't think it addresses that. Certainly, that wasn't the intent. The WebSocket is a two-way communication channel between the ADF file and the SCIEX Analyst software, but that's really the extent of what we've done there.
Okay, thanks.
Okay, if there are no further questions, thank you very much for your time. It's great to have an opportunity to show off a little bit. Thank you all.
Great, thanks.
Thank you.